Hello everyone, today we're going to learn about three laws of motion. These laws of motions are discovered by Sir Isaac Newton. The first one is first law of motion. This is also known as law of inertia. Inertia refers to the tendency of a body to remain at rest or continue moving. Or, in other words, it is the potential of a body to resist from any sudden change in motion. This law states that a body at rest will remain at rest, and a body in motion will continue moving at a constant speed in a straight path, unless an outside force will act on it. The mathematical expression for this is the net force is equal to 0, or sigma F equals 0. So if we have a body here, this body will remain at rest, or even moving at a constant speed in a straight path, if the net force is equal to 0. So if we have 15 newtons to the left, there must be another 15 newtons to the right, so that the resultant force is 0. The same applies with the y-axis. So if there's 10 newtons upward force, there must be 10 newtons downward force. The second one is second law of motion. This is also known as law of acceleration. Law of acceleration states that acceleration is directly proportional to the net force but inversely proportional to the mass. So A is proportional to the net force, but it is inversely proportional to the mass. Inversely proportional to the mass means that A is directly proportional to the reciprocal of the mass. So A is proportional to 1 over m. From this, we can get that A equals sigma F over m, where sigma F is not equal to 0. Because if sigma F equal to 0, it will become Newton's first law of motion or law of inertia. And then arranging this by multiplying both sides by m, we get that sigma F equals m times A. This will be the general equation we'll be using. For the third one, we have third law of motion. This is also known as law of interaction. Law of interaction states that for every action, there is equal but opposite reaction. The mathematical expression is F action equals to negative F reaction. So for example, if we have a body here, the body will have a weight which can be calculated by multiplying m by gravitational force g. For the body to not collapse to the surface, there will be an equal but opposite reaction, which is the normal force. So from this, we can get that F action equals negative F reaction. For this situation, we have weight will be the action force and normal will be the reaction force. So weight equals negative normal force. For example 1, we have the diagram below shows a particle acted by a set of forces. Given that the particle is at rest, find the value of P and Q. So we'll first focus at x-axis and I'll tell you why later. So this net force in the x-axis equals to 0. We follow the first law of motion because it is given that the particle is at rest. So in the x-axis, we have P newtons to the right, so positive P newtons, and 50 newtons to the left, so minus 50 newtons. So P newtons minus 50 newtons equals to 0. Transposing negative 50 newtons to the right side gives us P newtons equal 50 newtons. And then cancelling newtons on both sides, we get P equals to 50. Then we'll focus on the y-axis. So the particle is at rest, so the net force in the y-axis is equal to 0. So sigma Fy equals to 0. The sum of the force in y-axis, there's 5q newtons upward, so positive 5q, and 3p newtons downward, so negative 3p newtons, and negative q plus 10 newtons. So 5q newtons minus 3p newtons minus q plus 10 newtons equal to 0. And then dividing both sides by n gives us 5q minus 3p minus q plus 10 equals to 0. Then we can substitute p, which we calculated before. So 5q minus 3 times p, which is 50, and then expanding the negative sign gives us negative q minus 10 equals to 0. 5q minus q gives us 4q, negative 3 times 50 is negative 150, minus 10 gives us negative 160. Then transposing negative 160 to the right side gives us positive 160. So 4q equals 160. Then dividing both sides by 4 gives us q equals to 40. Now I'll explain why we choose to focus in the x-axis before focusing on the y-axis. So we can see that in the y-axis we have two variables, q and p. If both of them are unknown, we can't find either both of them. So we need to first start at the x-axis, which have only one variable, so that we can use this variable to substitute it into the y-axis to get the other variable, q. So for the second example, given that the particle in this diagram is moving with constant velocity v, find the values of p and q. Notice that the x-axis and y-axis both have two variables p and q. So it doesn't matter where we start first, but we'll start first at the x-axis. So sigma fx equals to 0. In the x-axis, we have 2p plus q newtons to the right side, so positive 2p plus q newtons, minus 25 newtons to the left side, so 2p plus q newtons minus 25 newtons equal to 0. Transposing negative 25 newton to the right side and dividing both sides by n gives us 2p plus q equals to 25. So we'll keep this equation first. So sigma fy equals to 0, this is for the y-axis. There's an upward force of 3p minus 2q newtons upward and a downward force of 20 newtons. So 3p minus 2q subtracted by 20 newton is equal to 0. Transposing negative 20 newton to the right side and dividing both sides by n gives us 3p minus 2q equals 20. So we have these two equations. These two equations forms systems of two linear variables. So we can eliminate one of them. We can eliminate p or q. It is easier to eliminate q as we just have to multiply 2 to the first equation. So we'll eliminate q. Multiplying the first equation by 2 gives us 4p plus 2q equals to 50. And then 3p minus 2q equals to 20. You don't need to multiply anything here. And adding them gives us 7p equals to 70. We add this because 2q and negative 2q have different signs. So to eliminate them, we need to add them. So 7p equals to 70. Dividing both sides by 7 gives us p equals 10. And then we can substitute p into the first equation or second equation. We'll substitute p to the first equation because it is easier as the coefficient of the variable is lower than the second equation. So 2 times 10 plus q equals 25. 2 times 10 gives us 20. Transposing it to the right side becomes negative 20. So q equals 25 minus 20. So q equals 5. So now for example number 3. The diagram below is said to be accelerating 2 meters per second squared. Find the magnitudes of the unknown forces x and y. So because this has already acceleration, we follow the second law of motion. So in the x-axis, it is moving at an acceleration of 2 meters per second squared. While in the y-axis, it doesn't move. So in the y-axis, we follow the first law of motion or law of inertia. So for the x-axis, we have law of acceleration. So sigma fx equals to m times ax. In the x-axis, we have x newtons to the right side, so positive x, and 4 newtons to the left side, so negative 4. So x minus 4 equals, the mass is 2 kilograms, and the acceleration is 2 meters per second squared. So x minus 4 equals 2 times 2. 2 times 2 gives us 4. Transposing negative 4 to the right side gives us positive 4. So x equals 4 plus 4 gives us x equals 8 newtons. Now for the y-axis, it follows the first law of motion or law of inertia. So sigma fy equals 0. We have an upward force of y and a downward force of 2g newton. So y minus 2g equals to 0. So transposing negative 2g to the right side gives us y equals 2g And substituting g equals 9.8 gives us y equals 2 times 9.8. 2 times 9.8 gives us 19.6. So y equals 19.6 newtons. So our answer for this question is x equals 8 newtons and y equals 19.6 newtons. For example number 4, if the body as shown in the diagram below is decelerating by 2 meters per second squared, find the magnitude of the forces x and y. It is somehow similar to the last question, but instead of acceleration, it is deceleration. For the x-axis, we have to use the second law of motion because it has an deceleration. And in the y-axis, it doesn't move, so we follow the first law of motion or law of inertia. So sigma fx equals to m times ax. We'll assume the left side is positive and right side is negative. So 8t minus x is equal to the mass, which is 4, times ax, which is 2. So 8t minus x equals to 4 times 2. Transposing negative x to the right side gives us positive x. 4 times 2, which is 8. Transposing 8 to the left side gives us negative 8. So 8t minus 8 equals x. So x equals 72 newtons. And then in the y-axis, sigma fy equals to 0. So we have an upward force of y newton, downward force of 20 and 4g. So y minus 4g minus 20 equals to 0. So transposing negative 4g and negative 20 to the right side gives us y equals 4g plus 20, which is equivalent to 4 times 9.8 plus 20. 4 times 9.8 gives us 39.2. Added with 20 gives us y equals 59.2 newtons. So our answer for this question is x equals 72 newtons and y equals 59.2 newtons. For the last example, we have a truck engine of mass 5,000 kg pulls a trailer of mass 1,000 kg along a level track at an acceleration of 0.100 meters per second squared. The frictions are 10 newtons per 1,000 kg for truck engine and 5 newtons per 1,000 kg for the trailer. So we'll do the A part first, draw a free body diagram for the truck engine and for the trailer. So we'll draw two body, a trailer which is 1,000 kg and truck engine which is 5,000 kg. They are moving at an acceleration of 0.100 meters per second squared. So they're moving to the right side at an acceleration of 0.100 meters per second squared. And because they are connected by a tow bar, there must be a tension between them. So there's a tension between them in the tow bar. And then there's also frictions. So there's a friction for trailer and friction for engine. And then the truck engine exert a forward thrust. So there's a forward thrust exerted by the engine. So this is for the A part. Now for part B, calculate the tension in the connecting tow bar between the truck and its trailer. You can choose which free body diagram to focus on. You can focus on trailer or truck engine. So if we focus at truck engine, we can see that we can calculate the friction, but we can't calculate the forward thrust. So we need to focus on the trailer because we can calculate for the friction and there's an acceleration given and mass, so we can find the tension. So because there's an acceleration, we follow Newton's second law of motion. So sigma F equals to m times A. In trailer, the sigma F are tension to the right side, so T minus the friction. So T minus Ft equals to the mass of the trailer times acceleration. Before we substitute the mass and the acceleration, we need to find the frictions of the trailer first. It is given in the question that the frictions are 5 newtons per 100 kilogram for the trailer. So we need to find how many 1,000 kilogram are there in the mass of a trailer, which is 1,000 kilogram. So in order to do that, we divide 1,000 by 1,000. So 1,000 over 1,000 multiplied by 5, which gives us 5 newtons. So T minus 5 equals to the mass, which is 1,000, times the acceleration, which is 0.100. 1,000 times 0.100 gives us 100, and transposing negative 5 to the right side gives us positive 5. So T equals 100 plus 5. So T equals 105 newtons. Now we'll do part C. Calculate the forward thrust exerted by the engine. So now we'll focus on the engine body diagram. Because this engine has an acceleration of 0.100 meters per second squared, we follow the Newton's second law of motion or law of acceleration. So sigma F equals to m times A. In the sigma F of truck engine, there's a forward thrust or Fe to the right side, so positive Fe, and a tension and friction to the left side, so Fe minus T minus friction E equals to the mass of the engine times the acceleration. Before substituting tension, mass, and acceleration, we need to find first the friction. It is given in the question that the frictions are 10 Newton per 1000 kilogram for truck engine. So we need to find how many 1000 kilograms are there in the mass of truck engine, which is 5000 kilogram. So 5000 divided by 1000 times 10, which gives us 50 newtons. So Fe minus the tension which we got before, which is 105 newtons. So minus 105 minus friction, which is 50, equals to the mass 5000 times the acceleration 0.100. 5000 times 0.100 gives us 500, and negative 105 minus 50 gives us negative 155. Transposing negative 155 to the right side gives us positive 155. So 500 plus 155 gives us 655 newtons. So our answer for the B and C are 105 newtons and 655 newtons. This is all for today's lessons. Thank you for today and see you tomorrow.